According to the National Electrical Code, Section 404.14, branch circuits required. Subsection D, feeders supplying luminaires states that a branch circuit supplying one or more luminaires shall have a rating not less than that marked on the luminaire or luminaires. This code section does not explicitly state whether it is permissible to have a 20 amp circuit breaker with a 15 amp switch. However, according to the NEC, Section 404.4, subsection D, protection, branch circuit shall be protected against overcurrent in accordance with the requirements of Article 240. Section 240.4, overcurrent protection, subsection B, location, states that overcurrent protection for conductors and equipment shall be provided at the point where the conductor receives its supply. Further, Section 240.4, subsection D, enclosures for overcurrent protection devices, states that overcurrent protection devices shall be enclosed in enclosures in accordance with 240.4, subsection D, paragraphs 1 through 5. Section 240.4, subsection D, paragraph 1, states that overcurrent protection devices shall be enclosed in a suitable enclosure. This could be interpreted to require that the switch be rated for the same amperage as the circuit breaker. Therefore, it is generally recommended to use a 15 amp switch on a 15 amp lighting circuit, even if the circuit breaker is rated for 20 amps. This is to ensure that the switch is adequately rated to protect the circuit and prevent overcurrent conditions. Firstly, consider the load requirement. The switch's amperage rating should always meet or exceed the maximum current a connected lighting load is expected to draw. If the lighting load is known to draw less than 15 amps continuously, a 15 amp switch might seem sufficient. Secondly, consider the NEC regulations. While the NEC doesn't explicitly forbid using a 15 amp switch on a 20 amp circuit, it emphasizes protection against overcurrent. A 20 amp circuit breaker protects the wiring from overload, but a 15 amp switch could become a point of failure if the circuit experiences a fault current above 15 amps but below 20 amps. Thirdly, consider the practical implications. Using a 20 amp rated switch would provide a higher safety margin, reducing the risk of switch failure due to overcurrent. It's a more robust solution, especially in situations where the actual load might fluctuate or increase over time. Fourthly, consider the potential for future upgrades. If there's a possibility that the lighting load might increase in the future, using a 20 amp switch from the outset provides flexibility and avoids the need to replace the switch later. Fifthly, consider the cost factor. The price difference between a 15 amp switch and a 20 amp switch is usually minimal. Given the increased safety and flexibility, the slightly higher cost of a 20 amp switch is generally justified. Sixthly, remember the purpose of circuit breakers. The primary role of a circuit breaker is to protect the wiring in the circuit from overheating, which can lead to fires. The circuit breaker is sized according to the ampacity of the wiring. For example, 14 gauge wire is typically protected by a 15 amp circuit breaker, while 12 gauge wire is typically protected by a 20 amp circuit breaker. Seventhly, consider switch ratings and applications. Switches are rated for both voltage and amperage. It's crucial to use a switch that's rated for the voltage of the circuit it's being used in. In North America, most residential lighting circuits are 120 volts, so a switch rated for 120 volts is appropriate. Switches also have different types for different applications. For example, single-pole switches are used to control a light from one location, while three-way switches are used to control a light from two locations. Eighthly, remember that the weakest link determines the circuit's safety. In this scenario, the 15 amp switch is the weakest link. If an overcurrent situation occurs, the switch is likely to fail before the 20 amp circuit breaker trips, potentially leading to a hazardous situation. Ninthly, think about the consequences of switch failure. When a switch fails due to overcurrent, it can melt, arc, and potentially start a fire. Using a switch with a higher amperage rating than the expected load reduces the risk of switch failure and enhances safety. Tenthly, keep in mind the importance of proper installation. Even if the correct components are used, improper installation can compromise the safety of the electrical system. Ensure that all connections are tight and secure and that the wiring is properly insulated. 11thly, consider the role of local electrical codes. Local electrical codes may have specific requirements that go beyond the NEC. It's important to be familiar with the local codes in your area and to comply with them. 12thly, think about the long-term reliability. A 20 amp switch is likely to be more durable and reliable than a 15 amp switch, especially in applications where the switch is frequently used or subjected to heavy loads. 13thly, consider the potential for inductive loads. Some lighting fixtures, such as those with ballasts, can create inductive loads that generate higher inrush currents when the switch is turned on. A 20 amp switch is better able to handle these inrush currents without overheating or failing. 14thly, think about the potential for voltage drop. Using a switch with a higher amperage rating can help to reduce voltage drop in the circuit, which can improve the performance of the lighting fixtures. 15thly, remember the importance of regular maintenance. Electrical systems should be inspected regularly for any signs of wear or damage. Switches should be checked to ensure that they are operating smoothly and that there are no loose connections. 16thly, think about the potential for arc flash. Arc flash is a dangerous electrical phenomenon that can occur when there is a fault in an electrical system. Using properly rated components and following safe work practices can help to reduce the risk of arc flash. 17thly, consider the benefits of using arc fault circuit interrupters, or FSIs. FSIs are special types of circuit breakers that are designed to detect and interrupt arc faults, which are a common cause of electrical fires. The NEC requires FSIs in many circuits in new homes. 18thly, think about the benefits of using ground fault circuit interrupters, or GFCIs. GFCIs are special types of receptacles that are designed to protect people from electrical shock. The NEC requires GFCIs in many locations, such as bathrooms, kitchens, and outdoor areas. 19thly, consider the importance of proper grounding. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electrical shock and prevent damage to equipment. 20thly, remember to always turn off the power before working on any electrical circuit. This is the most important safety precaution that you can take. 21stly, consider the value of professional expertise. If you're not comfortable working on electrical circuits, it's always best to hire a qualified electrician. A licensed electrician has the knowledge, skills, and experience to safely and effectively install and maintain electrical systems. They can also help you to ensure that your electrical system complies with all applicable codes and regulations. They can assess the existing wiring, the intended load, and any specific local requirements to make the best recommendation. In summary, while it might not be strictly prohibited by the NEC to use a 15 amp switch on a 20 amp circuit, it's generally not recommended. Using a 20 amp switch offers a greater margin of safety, reduces the risk of switch failure, and provides flexibility for future upgrades. It's always best to err on the side of safety when dealing with electrical systems. Consulting with a qualified electrician is crucial to ensure that the wiring and components are appropriately sized and installed for the specific application, adhering to all relevant codes and regulations. Remember that electrical safety is paramount, and taking the necessary precautions can prevent accidents and protect lives. Proper planning, component selection, and installation are key to a safe and reliable electrical system. Always prioritize safety and seek professional guidance when needed.